Have you ever really stopped to think about what happens when you run your JavaScript code? You write it, you hit run, and things just work. But it's not magic. There's a whole process happening under the hood, and we're about to pull back the curtain and see exactly how the JavaScript engine brings your code to life.
So let's ask that question directly. You declare a variable, you write a function, you call it. What's actually going on, step by step, to get your result? Trust me, it's not a black box, and getting a handle on this is one of the biggest steps you can take to level up as a developer.
The whole secret really boils down to one core idea, the execution context. You can think of it like a big container or special environment that JavaScript creates to run your code in. Literally everything that happens in JavaScript happens inside one of these execution contexts. All right, so let's pop the hood on this engine room and see what it's made of. Because an execution context isn't just one thing. It's actually got two very distinct parts that work together to make everything happen. So inside this context, you've got two halves. On one side, you have the memory component, sometimes called the variable environment. This is basically a ledger where JavaScript keeps track of all your variables and functions as key value pairs. And on the other side, you've got the code component, or the thread of execution. This is the active part that actually goes through your code one line at a time and runs. Now, that one line at a time thing, that's absolutely crucial. See, JavaScript is what we call a synchronous, single-threaded language. Single-threaded just means it can only do one thing at a time, and synchronous means it has to finish that one thing completely before it can even think about starting the next. It has a very, very orderly one-track mind. So how does this execution context get set up in the first place? Well, it's not a one-shot deal. The JavaScript engine actually makes two separate passes over your code. It's a two-phase process. And here they are. First, there's the memory creation phase. This is where the engine just sets aside space for all your variables and functions. It's just prepping. Only after all that is done does it move to phase two, the code execution phase. And this separation is the real secret behind some of JavaScript's most famous quirks. Okay, enough theory. Let's get our hands dirty and actually walk through a simple program. We've got a variable n set to 2, a function called square, and then we call that function a couple of times. Let's see exactly what the engine does, phase by phase. Okay, here we go. Phase 1. The JavaScript engine takes its first look at our code from top to bottom. But, and this is the key part, it is not running anything. Not yet. It's just scanning for any variable or function declarations so it can set up the memory ahead of time. And boom, this is what our memory looks like after that first pass. The engine found our variables n, square 2, and square 4, and it's allocated space for them. But notice, since no code has run, it gives them this special placeholder value, undefined. Now, for the function square, it's a little different. It actually takes the entire function's code and stores that in memory. All right, memory is all prepped. Now for the fun part, phase 2, code execution. The engine circles back to the top of our script, and it's finally ready to start running our commands one by one. First line up, var n equals 2. Simple enough. The engine goes to its memory, finds n, and swaps out that undefined placeholder with the actual value 2. Done. It then sees the function definition, knows it already stored it, so it just skips right over it for now and heads to the next real command. And this is where things get really, really interesting. We've hit a function call square, n. Now, this isn't just another simple line of code. Invoking a function is like launching a whole new mini program right in the middle of our main one. Because here's the magic trick. Every single time a function is called, JavaScript spins up a brand new, shiny, temporary execution context, just for that one call. It gets its own private memory, its own thread of execution, and, you guessed it, it goes through that same two-phase creation process all over again. So if we zoom in on this new context for square of n, we see that in its own little memory creation phase, it sets up space for its parameter, num, and its local variable, ans. Then, in its execution phase, it takes the value of n, which was 2, and assigns it to num. Then it runs the code, calculates 2 times 2, and assigns the result, 4, to ans. Then we hit the return ans line. This is the function's exit ticket. It does two critical things. First, it packages up that final value of ans, the number 4, and sends it back out to where the function was originally called. Second, as soon as that's done, the function's entire temporary execution context is just deleted. Poof.
Its job is done, so it's wiped from existence.
And just like that, we're back in our main global execution context. That value of 4 that got returned, it's now assigned to our square2 variable. Then the engine just moves on to the next line and does the whole dance all over again for square 4. A new context is created, it calculates 16, returns it, that context is deleted, and finally the value 16 is assigned to square 4. This is the final state of our global memory. Okay, you're probably wondering, that's a lot of little worlds being created and destroyed. How on earth does JavaScript not get totally lost, especially if you have functions calling other functions? Well, it has a manager, a master conductor, if you will, called the call stack.
And the call stack is, well, exactly what it sounds like. Think of it like a stack of plates. When your program starts, the main global context is the first plate on the table. When a function gets called, its context is put like a new plate on top of the stack. When it's done, you take that top plate off. It's a last-in, first-out system, and it keeps everything perfectly organized. So let's watch this in action. The moment our code starts running, bam, the global execution context is the first thing pushed onto the stack. It's the base of everything.
Then, when we call square of 2, its brand new execution context gets pushed right on top. Now, the JavaScript engine is only paying attention to whatever's at the very top of the stack. That's the currently active context. That's the code that's running right now.
And once that function hits return and finishes its job, its execution context is popped right off the top of the stack. It vanishes, and control immediately returns to whatever context is now on top. In our case, back to the global execution context, which picks up right where it left off.
And just a quick heads up, because you're going to hear a ton of different names for this thing out in the wild. People call it the execution context stack, the program stack, the control stack. They all mean the exact same thing, so don't let the different names throw you off. It's all the same powerful idea.
So there you have it. That's how JavaScript uses the execution context and the call stack to run your code in a perfectly orderly, one-thing-at-a-time fashion. It's a beautiful system. But wait a minute. If it can only do one thing at a time, what happens when you ask it to do something slow, like fetch data from a server? How does the whole page not just freeze? Well, that is where the rest of the JavaScript story begins.